Yeah, I'm be the last talk of the day. There's quite some overlap with the last talk, so I try to keep it quick, and we will dive a little bit into the nix-shell and what we can do with it for development environments, and all of this from the perspective of a like everyday or real life project that we work on. Yeah, okay, I got this picture from Tumblr there. I like it. And okay, a little bit background. I'm Peter, working at Blockstream in the core Lightning team, and there I'm mostly working on Greenlight, and I'm also currently I'm the maintainer of the PeerSwap project, and that's where all of this talk originates from, or all that we will see today, is because we also use we use Nix there for our development environments and also our CI. Yeah, it works on my machine. That's a quote from an unknown software developer. I guess could be everyone. I guess everybody heard this quote before, and it's yeah, it's a horrible thing. It shows that or you typically say it if you don't know what's going wrong or why things are not going as you wish. And we may see or we may find out about how Nix can help us to avoid this sentence and to maybe never hear it again. Okay, yeah, that's a picture. Is it readable? Yeah, maybe a little bit. Let's go through some of them. That's the top 20 replies by programmers when the programs don't work. Yeah, and some of them are like, for example, number 18, it worked yesterday. Heard this before. How is that possible? Heard this before. It must be a hardware problem. Also heard this before. And some of them we might get rid of today. Okay, when we say it works on my machine, what are we talking about? It's mostly that we have software or code that behaves correctly or produces bugs on my machine, but not on other machines. And both is horrible. I mean, if it works on my machine, it doesn't work on a different machine, that's horrible. But also if it produces bugs on my machine, but not on a different machine, that's also horrible. And what can we do about it? And there comes nix-shell into play and nix-develop. And Eric already said something about nix-develop, and that's what we're going to dive into now. A little disclaimer, I'm not a Nix expert, so if you have any Nix questions, ask Matthew, for example. He runs a consultancy on Nix, so this talk will stay on a pretty high level, and we will just explore what the nix-shell can offer us for local development. It's based on the PeerSwap repository. It includes some live coding, so that could go horribly wrong. And it is basically 3 parts. We will start with a short explanation, then we will go through what is needed to write a flake for our nix-shell, and last part might be a little rant about Docker. Okay, what is PeerSwap? I don't know if you're familiar with the project. It's an atomic on-off-chain swap protocol. Sometimes people refer to it as submarine swaps. What we do is we enable Lightning nodes to swap Lightning liquidity to Bitcoin or to liquid Bitcoin. It comes with some executables. We have a plugin for core Lightning, we have a standalone daemon for LND, and we have a command line interface also for the standalone daemon, and it's written in Golang. A little bit about this, so to explain what the project is about and also where the dependencies are coming from. So Go for is this, I mean, it should be clear, the program is written in Go. We also depend on bitcoindev for integration tests, same as with elementsd. Also, we rely on core Lightning for integration tests and cross-implementation tests. And there are 2 flavors, one with developer flags enabled and one without. LND, OpenSSL for certificate stuff, Bolt browser to inspect the Bolt DB, and Go tools, I have no clue what these do, but they are also there. JQ to make our lives a little bit easier. Mermaid CLI to produce beautiful state diagrams from our state machine. And then a whole bunch of protobuf stuff. And all of these have versions. And that's bad. Here are some real-life examples of how, for example, if you have different versions of protobuf on Protalk, the compiler, I don't know if you're familiar with it, but it changes quite often, and most of the changes are bike shedding changes. It's like as you see in the bottom lines, it just changes some naming stuff, And if now I have one version and my co-developer has another version, then we will have these kind of commits back and forth, and it will never stop, and it's just annoying. Also, APIs can change through versions. Top example is a quite heavy one from Core Lightning. I don't know when this was introduced, 2305 or something, I don't know, but it was called the Great MSAT Purge, and it broke quite a lot of applications. Also behavior can change. The lower example is from LND, where a channel update without max HTLC message flags that are now recognized as invalid and are not relayed. So these things can happen that they fail on one machine but not on the other if we have version drifts under our developer team or something. And also, yeah, CI fails, but it works on my machine. That's always good. Okay, nix-shell is here for the rescue. And what is the nix-shell? It's an environment created by the Nix package manager, but please correct me if I'm wrong on anything about this. I'm not, as I said, I'm not a Nix expert. Yeah. And it can be spawned and contain Nix packages, and so we get access to these Nix packages. It basically just manipulates the path, the environmental variable for the path, and it can be used to create isolated and reproducible environments. And now the fun part begins. We start to demo something. Okay, Okay, for example, let's say I want to say cowsay hello Berlin. I don't have cowsay installed. So what can we do about it? We can say, oh, I copied it already, didn't I? Yeah. We just spawn a shell with it, and if we run it again, oh, what's happening here? Cowsay hello Berlin, and now it works. We just have it here. We close our shell, we try it again, and it's gone. So we may also want to have a deeper look on what is happening there. So what we can see is that cowsay points now to path in the Nix store, and all this number stuff here, that's responsible for giving us the so-called reproducibility. It's a hash that's based on the inputs of the derivation and stuff like this. So that's basically the thing that's under the hood is like giving us the reproducibility, heavy word. We also could explore, I don't know if this is a good idea to do this, but let's say, yeah, we can see there's a whole lot of stuff of Nix added to a path variable. That's what basically going on there. Okay, oh, now we have to click index again. Okay, yeah, I find this is pretty amazing. We can open a shell, we have a program, and we close it and it's gone. I mean, come on, it is amazing. Okay, back to peer swap. What do we want for our project? We want the same Go version across all developer environments and also for CI. We want to run integration cross-implementation tests locally and on CI. We want to experiment with LND and Core Lightning locally. We want to build documentation, generated stuff. We want to compile proto in the stuff, and we want to debug the database. And we also want to keep our own shell, and we don't want to use anything else because we like our shiny shells. And what we do not want is any of the dependencies to bleed into our host system, into our own system. Okay, let's check on these. Did we exit the shell yet? No. Okay. No, should. Okay, if we now run, for example, make all docs, that's what building the documentation in background, it doesn't work because it says it does need some program that's called MMDC, and it doesn't work. Okay, same here again, we can just, what is this, mermaid, how is it called? I have to copy it from here. We can open a shell that contains our development dependency, and now we can build the documentation, and now it works. Yeah. So we could call it a day and say, okay, that's it. We don't need anything more. We could just add all of these up in this kind of like command, and we start our shell and we call it a day. But that is rather painful. So we can use a flake to do this for us, or to keep this organized, so to say. Short reminder about the flakes. There's a whole lot of stuff that's standing here. That's from the official documentation. I highlighted the stuff that's interesting for us, and that is it's new, it's experimental, and it's also super fast. So that's enough arguments. We use it. And as a short reminder, a flake is a set that has inputs and outputs, and the inputs are basically dependencies, and the outputs could be multiple outputs. Could be packages, templates, configuration, or also environments, and that's what we are going to use it for. And also, Flake comes with a log file, so if you build it, or if you open the shell, or if you interact with it from the nix commands, it will produce a log file that is also saving reproducibility, or giving us reproducibility. Okay, this is how something like an easy version, or in contain, or how to say, like a, yeah, what the Flake can look like. We can go through it step by step. First line here is loading the nix packages as an input. Second line is loading the Flake utils as an input. That's some kind of helper functions that help us to deal with the kind of system things that are under the hood. Like here we call it with the, or it gives us the system argument, and we can inherit of system so that we can build it for different architectures. That's not. But we don't have to understand this. And yeah, and that's the important part, or the fun part is starting here. We can say, oh, I cannot really highlight this. We can say, we want to spawn a dev shell. We use the make shell call for this, and we can give it some packages that it should contain. And that's something that we can, let's give it a try. So this is the flake.nix file. We save it, we run it. Oh, I'm still in a shell here. Oh, something went wrong. By accident, totally by accident. And you can see that the tool is also pretty helpful to us, and is trying to help us to write the right code. And obviously there's been a typo, so it even tells me what I should have done. So let's do that. What was an M here, wasn't it? Yeah. Okay, let's do this again. And we are in the shell. Now what did we give it? We give it cowsay also. Let's check if this works. It works. Okay, cowsay is pretty useless, but we could now give it all the dependencies that we specified in the beginning that we need for this program or for our project. Oh, how was the code block? It was with the dev shells, was everything. Okay, exit the shell, enter the shell, it's evaluating. I luckily got all cached, so it didn't take that long. And now we can see, if we, for example, check on which versions we are using for Go, it is Go 119, the one that we specified in the build inputs. I'm not really sure why they make this, why they distinguish between build inputs and packages. That might be questioned for some expert, but basically they use all the fields or attributes that you also have when you make derivations, more or less. Okay, yeah, I mean that's more or less what we want. One further thing that we wanted was to have a core lightning in two different flavors, one with the developer flags enabled and one without. And luckily, derivations can be overridden. So it's called overridables, and derivations are overridables, and we can use a command that's called override derivation to basically override the build process of our derivation or of our package that we load there. We can see it here. First I put it into code, and then we can go through it a little bit. Packages, I guess it should go here, somewhere here. Yeah, seems fine. Okay, what it does is, it gets some attributes, and then we can override the attributes of a derivation. In our case, we add the configure flags, enable developer, and we give it a different name so that we can distinguish it from the original version. And then we also have to add it to our packages. And we may also want to make it usable by our tests. And we define some variables, some environmental variables for this. This can also easily be done with the shell, with something called the shell hook, that is basically something that is called when we start our shell. So on startup, the shell hook is called, which we will see with the echo line also there. So am I still in the shell? I am. I was. Okay, let's check on this. Develop. Oh no, it's downloading something. But yeah, here's what was dirty. The Git tree is dirty, yeah. But okay, this is building core Lightning now in the back for us with the configure flag enabled. Let me try if I can speed this up a little bit by pinning to this version of the Nix packages, which is basically what we can do to ensure the versions, or to also have different versions. If we want to have core Lightning version 23 or 5 and also in 23 or 8 or something, that could be done by pinning to the revision of the Nix packages repository. Did I copy the whole line? No, I should copy the whole line. Okay, now I did. And let's see if, I guess I pre-built this one, and this should then be faster. Let's interrupt this here. Let's start this again. Yeah, okay. I pre-built this one. Now we can, what did I call this? Lightning something. Lightning d_dev. So, and we can see that this is now, it also has, we changed the name, if we recall this, and it also has changed the name here. That's also something that I find pretty amazing. Let's go a little bit, let's also talk about this section here. What we do with the $sign and the curly braces is Nix internally will look up where this package is stored, and then we'll print out the path to it. Okay, that's it. Back to PeerSwap. So we got same Go running on all machines, run integration course implementation test locally. We could show it that they take forever, but I can just show that they will start to run. So this builds the program, and yeah, now all the tests are running, but it's a bunch, and they take forever. Okay, we can experiment with LND and core Lightning in our shell. As I showed, we could easily use LND now on the shell, even though we don't have it on the host system, or installed in or usable in our host system, so to say. We can build a documentation. We showed that. We can compile proto and all of these stuff. We can debug the database. Still open that we keep our own shell. I don't know if you recognize or saw this, but this now we have a, how do you show this? Do you do it like this? Yeah. We are running in a bash, and originally the system uses ZSH. C#. Okay, so that's also something that we want to have, so that we don't have that we don't even recognize that we are running in a nix-shell here, and it just feels like our home system. That's also astonishingly easy to do. We just have to use derenv. I don't know if maybe derenv is something that people know about. And derenv can, it basically what it does is it checks your working directory for a file that's called .envrc, and if it finds this, then it loads the subshell and makes the environmental variables, given if this .envrc file available to the shell. So basically it loads and unloads environmental variables. And it could also be used to drop us into a nix-shell by simply adding, oh, I've already done it here. Simply adding these two words and a dot. And how does this look like? Are we in a shell still? No, we haven't been. Damn. I will make this bigger again. Yeah, but you saw there's a whole bunch of things happening there. How do I make this bigger? Is it this one? Yeah. And basically, it just loaded a lot of environmental variables, and you can also see a whole bunch of Nix stuff that has been loaded there. And if we now check on which Go we're using the one that we set in our flake. So this is quite easy to use. I mean, I just have to enter my directory, and it's all set up for me automatically. Boom, next mind-blowing moment, for me at least. It's, yeah. Okay, we could now call it a day, but well, hello there. There are other options to maybe achieve something similar. First thing that might come to your mind is why not use Docker? A whole lot of reasons, but I mean, yeah, if you've seen this on the left, they also try to claim that they fixed the it works on my machine problem. Let's check if this is true. We have here a whole bunch of articles, Medium articles that try to explain how Docker fixes this. Let's just check on the last one here. They also claim it, and luckily for us, they gave us a GitHub repository to show how it fixes this, and let's check if it really does. Not to blame the developer here. I mean, they did great work. Okay, so they have, it seems like some JavaScript stuff with package JSON, package something. It is a log file here, so that's good for them. Let's check the Docker file. Okay, first line. From Ubuntu, what is that? So, I mean, I don't know if you already see why this is really problematic. Let's maybe ask Ubuntu to help us here and to explain to us what that means. And yeah, okay, they tell us what Ubuntu latest is, what Ubuntu rolling is, what Ubuntu devil is, but what is just Ubuntu? I don't know. I don't have any idea what it is. So it could be latest, it could be an LTS version. We have no idea what kind of version this is loading. Okay, then they load a bunch of stuff. Oh, that's also, the layering is wrong. If somebody recognizes, you shouldn't copy the stuff before you update us. Yeah. Run update. Which version of npm are they installing there? I have no clue. And they also don't have a clue. So what can happen is, if two individual people are running this Docker file to create themselves an environment in which they build or experiment or develop, they can have completely different versions of npm that they run. So I would say it doesn't fix the problem. And no, not, yeah, kill a whale. No, please don't, we love our whales. But there are a few reasons why Docker might not be the tool we are looking for. One is also privilege escalation with Docker. So basically, if you run Docker, you are running root. You could mount any kind of directory and work on it as if you were root without using sudo. I mean, you can set it up the right way, but that's default mode, and that's not a good default mode. We don't get, or with Nix, we get guaranteed reproducibility in the Nix sense, what they mean with reproducibility. We haven't that much time dependencies as if we work with apt, for example, in Docker file, where we are highly time dependent on when we run this build script. And we can keep our own shiny shell and don't have to use like something that was set up for us there. We are also, Nix can also be used natively on Mac. I mean, Eric also said this, and it comes with some drawbacks, yeah, but it works. And finally, if you ship Docker, then please at least build your Docker files with Nix. That's also possible. Okay, bonus gig. Yeah, I just also wanted to point out that there are Nix actions. We can actually look at how we set up CI here. Oh no, that's wrong. Oh, yeah, please don't see that there's Docker stuff. Okay, we can set it up. We have action set up. Yeah. Oh no, wait. Yeah. We can even cache all the stuff that we do there, and we can just use the standard cache that Git gives us with a cache action, and just hash the files. Hash our, oh, this is an old version that still has the packages on Nix. Should then be the flake.nix. Store the stuff there. We can import the stuff from cache so that we don't have to build it up every time again. And basically, we just call nix-shell run make test, and that's it. CI is set up, and it's running the same versions as we use locally across all machines. Then also I wanted to mention that there are tools. I mean, you already mentioned Nix cannot fix Python, but there are tools for to port your poultry stuff over to Nix and to move your Go mode stuff over to Nix. There are a whole lot of things that you can do with it to give yourself a better development environment. Okay, yeah, I guess we made it. would call it a day for, yeah, and if you have any questions, please ask the experts. Good. No, but real, if there are any questions, I'm happy to answer, if I can.
Here. Was that repo that you showed of a Docker file, like it runs on my machine demo? Was that a real demo? I feel like it was like an ironic demo.
This is an article that I found, and it claims that Docker fixes the it works on my machine problem with a link to this repository, and
it has that line from a bunch. I mean, I just feel like, yeah.
It was too easy, wasn't it, to show why this doesn't work? It was way too easy, but
yeah.
I mean,
well, I guess either way,
yeah.
Much appreciation to them.
I mean, maybe it was satire, but yeah. Okay. Oh. Yeah, you should answer your questions yourself.
I don't know if you know this, but if you run Docker,
yeah.
it actually fixes the reproducibility issues.
Perfect. I mean, you basically do if you run it in CI on GitHub, don't you? I mean, aren't they based on Docker? Is it not Docker in Docker then already? But now we can run nix in Docker. That's also done. Okay, yeah, thanks.